Hello, and I'm back. I made it out of Georgia. It was awesome. Savannah's a beautiful city. Really, really fun place to visit. And I got a new hat. I got a hat that is the Savannah Bananas, which is their farm league team. I did not see them play. I'm not even really much of a baseball fan, but I love the whole concept. Basically, I guess they fool around kind of like the Harlem Globetrotters. They have all kinds of traditions and whatnot, even though the name for the Savannah Farm League team, Savannah Bananas, is actually pretty new. It's created quite a stir. It is the deal that's going on in Savannah right now. So you can't get tickets to go see these people. It's sold out a year in advance. And so they're really, really proud of their team. And I like the logo, which was really cool. So we're back here in Research Methods, and we are in week 7. And we're going to be looking at what I believe may be one of the more challenging of chapters, and that is power and effect size. Now, these two items have to do with some of what we were talking about in the last chapter when we talked about sampling. And really what we're looking at is the description of a problem that is plaguing the field of psychology. It's plagued the field of psychology for a long time, but I think it's even more important now. And that is the issue of sample size and effect size and the power of statistics. Those three elements and how they work together. So let me review that in addition to the material in the course book, how I conceptualize these things. Now, as psychologists, what we're looking for is to find important relationships between variables. We see one thing, we see another thing. Are they related to each other? Does one cause the other? Does one increase the likelihood of the other? That's what we're looking for. We're looking for those, if you're playing video games, does it increase your sense of violence? Which, by the way, it does not. There's no evidence for it, at least. We want to see the relationships, so we're looking for relationships between variables. We use statistical tests in order to determine whether or not our findings are statistically significant, and therefore the data that we've collected and the results that we have are different enough from what we would expect by just the random occurrence of our variables in the world. So we set a line in the sand that we're going to have to see a significant difference between the decision, that determines the decision as to whether there is a relationship or whether there is not a relationship. Now, the piece that comes into play is if there is a relationship, if there is a cause-effect relationship and it's statistically significant, that's factor number one. The other important factor is the effect size, meaning is the relationship, which is statistically significant, also producing does it make a big difference or a little difference? And the way we like to look at that, to explain that kind of big difference, little difference, what we call effect size, would be, go back to my classic example that I use. I use PowerPoints in my class. I use slideshows in my class, and I hope that they help people learn. So I could do an experiment. I could have one class get the material without the slideshow. I could have another class get the material with the slideshow, test them both, and see if there's a difference between the average score. That would, classic to, a classic, I can't come up with the name, too much Georgia in me right now. A classic t-test, matched pairs, t-test to determine that. And let's say there is a difference and it turns out to be significant. Well, how many point difference? And let's say it would be 3-point difference. the average grade over here was 87, the average grade over here was 90. Well, that means it might be significant, but it's only 3 points. So then you have to do what in business they call an ROI, a return on investment. Is it worth it to do all the work on those slideshows if on average it's only going to be a 3-point increase? A lot of the, let's say, test prep organizations, let's say, that try to get you to take their classes in preparation for the SAT or something like that, always report significant effects. And I'm going to tell you why they can do that. But the actual effect size is really small. When people have taken those tests, yes, they've consistently increased their grades, but only by a little bit, maybe 3 or 4 points. So you got to wonder, well, how is it worth paying the thousands of dollars that sometimes these cost to get an average of 3 or 4 points on the SAT? So we're looking at something that's significant, but has low effect size. And maybe you're asking yourself right now, well, why are we still calling it significant? Great question. I'm going to answer that right now. And we call it significant because this little trick that is it's a Achilles heel. It's the fundamental problem of statistics is the sample size is a huge factor in determining whether something is going to be significant or not. Let me say it this way. Let's say that I have this SAT prep and I show that 10 people who took my test, took my class, increased an average of 3 points. That would probably not be significant because there's variability among those 10 people that would sort of outweigh the average change, because there's only a few people. So you might get people all over the place, and there's not a whole lot of, there is a whole lot of variability. If, however, I am able to demonstrate that the 3-point change occurred over thousands of people, I'm almost guaranteed that's going to be statistically significant, even though the effect size is small. Big samples make a big deal out of little changes. Hold on to that statement. Big samples make a big deal out of small changes. It's just what's out there. And now, I know as I'm talking to some of you are looking at studies where there's thousands of participants. I'm going to tell you why. Not because it's easy to get thousands of participants. Here's the problem in psychology. Many people conduct studies and make sure they have thousands of participants because that almost guarantees that they're going to find something significant, even though the effect size might be small, and they'll get published because it's easier to publish studies that have significant findings than it is for ones that don't have significant findings. In fact, it's difficult to find publications where there is no significant findings. Now, put that in the culture, and I know this is maybe TMI, but put that in the culture of psychologists who, in order to keep their jobs, have to publish. It's the publisher perish sort of thing. They have to show that they're publishing thing. It's damned if you do. You're damned if you don't do it. I was going to use that other statement, but that's not appropriate. If you get published and you have a lot of things going on, chances are you're going to get tenure. You're going to be able to stay in your job. So there's underlying motivation to make sure you get something significant. And then they might explain, they're still honest. They'll say, yeah, we got significant, but there was a small effect size or something like that. But that's how they got published. So here's an ongoing issue. When we come to conclusions based on large sample size, it might just be the statistics of sample size that are making something significant. We have to look beyond that and say, well, did it really make a big difference? That's what we want to know. And so that's the relationship between sample size effect size, and power. Now, power, based on your sample size, is a variable that says this statistic test that you're using has a good opportunity to make sure that your statistical tests are significant. It will not, it's not technically that it will make it significant, it's going to reduce the type 2 error. There'd be less chance of a type 2 error. And so when we have large sample sizes, we blow that thing out of the water, of course. But sometimes what we can do, and what I'm going to be asking you to do, is using that tool to look at existing parameters that you have regarding a study and determine what's the minimum sample size that I need in order to achieve that outcome. Now, that's kind of a different way of using power. Power is usually the other way around. The study's done, and you can do a power analysis to determine whether or not the statistics were good enough for what you got. You can also use the same tool, just solving for a different variable. You look at the preponderance of the evidence in the area that you're looking at. In your case, you're going to be looking at your existing study that you're replicating, and you're going to be determining, with my help, I want to offer my help in doing this because I'm not good at it either. Maybe the two of us will figure it out. What is the actual effect size of that part of your particular study? And then working the other variables into that software program called G-Power, determining how many people is ideal for you to get as a sample in your study. And then due this week is the special assignment on how are you going to get that many people. That's a lot. Just through a whole lot about the relationship between power, effect size, and sample size. You'll learn much more by doing. So chapter 8 essentially asks you to discuss what I just talked about. The whole issue with large sample sizes, the fact that it's difficult to publish something unless it has significant results, and the sort of issue with that. The quiz has you download that free app called G-Power and fill in the blanks based on some correlations. And I'm going to show you a little bit of this here. Here is the assessment section for chapter 8. Here's the size problem here in terms of sample size problem. And then here's the quiz. There are 4 case studies, and what it provides is it tells you how many tail the test is. They're all correlations, and this is the correlation that is reported here. Our alpha significance level is 0.01 or 0.05, and power is set at 80%. 80% is considered, that's the minimum statistical power that your test should have if you're going to, make some conclusions about it. So we're going to keep that constant across all of these, and you'll see that through each one of these problems, I've moved from, here's a two-tailed, I've changed the correlation, I've kind of switched around the alpha between 0.01 and 0.05 here. And what we're left with here, this is what the application G-Power looks like right here. And what you want to do is go, in terms of the test families, you can do exact testing, F-test, T-test, chi-square, and Z-test. You might remember some of that from statistics. We're going to do an exact one, and we're going to be looking at a correlation, a bivariate normal model among all these different kinds here. We're going to just look at that one. That's going to be for all of these. So here's your parameters. So I'm going to do the first one for you here. We have a one-tailed study. I'm going to switch that to 1. The correlation, the H1 correlation, the alternative hypothesis correlation, we guessed to be 0.25. The alpha is going to be 0.01. The power is going to be 0.8. That's 80%. And the probability of the null hypothesis, that's what that is 0. We just set that for 0, meaning it's all that hypothesis. So a 0.25 correlation on a one-tailed test at the 0.01 decision-making level, given a power of 0.8. And you look over here, all these questions over here are soon to be answered. I press calculate, and right there, you see the critical R is 0.18. The sample size right there is 157. In order for this kind of statistic to hold water and have enough power, I need 157 people to sample. What you'll be doing in the special assignment is trying to fill this out based on your original study, based on the study you're replicating, so it will spit out what is the minimum sample size that you need to get as you're trying to replicate it. Now, finding this right here, because they might have done a correlation, or they might have done a t-test, and you'll have to figure out what's the t-test here. And instead of the correlation was the effect size on the other one, this actually has an effect size on it. You have the 0.05, you have the power, those are all the same, whether it's a two-tailed test or not. But finding this effect size is not always easy. Okay, but say we had a two-tailed test here, and the t-test was done in your study, the effect size was 60%. I mean, a 60% change in due to the conditions, the 0.05 criteria, and we're going to use a power right now. We'll change that to 0.8 again, staying consistent here. And if I calculate, I only need 17 people. 0.6 is a very high effect size. That's a 60% change, kind of. You can look at that. So I only need 17 people in my study. So to do that. So you'd be playing around with this tool in order to determine sample size in your study. That's the special assignment. For the quiz, I just did the first one, so I'll know if people are watching this video. Everybody should get the first one. Just did it. Do those 4 case studies, and you're just entering. Remember, the detail-oriented. If it's two-tailed, one-tailed, it's going to make a difference. If I've changed the alpha from 0.01 to 0.05, that's going to change things. Make sure this is all very accurate. Holding power constant at 80%, and then answering that question. This should grade itself. I have the correct answers in there. It should grade itself, so make sure you put in just the number. Don't put sample size. Don't write sample size. Just put the number. How many do you need as your sample size based on those criteria? Okay, so we have a discussion on the large sample problem. We have a quiz doing these 4 examples of using the G-Power software to determine that particular research study's minimum sample size. And then the sampling plan special assignments, one part of it is determining the sample size based on what you know from your original study. That would be the preponderance of the evidence. We're just going to focus on that one. When I did my dissertation, I had to look across different studies and kind of figure out what is happening out there in terms of what kind of effect should I see? What level of correlations should I see based on what's out there? And sort of guess, really. As long as I was able to justify my guess, I said, this is what I think the correlation will be. I did a power analysis, and it determined how many people in my sample I needed to get in order for my choice statistics, which was a multiple regression, in order for that to work. Now, in the end, you will strive, and in the paper, I'm asking you to develop a specific strategy, maybe multiple steps, to try and get your sample size that high, depending on the power analysis that you do. In the end of the day, you're not going to be held to that. If you have to get 67 and you get 42, we're going to go with it. Okay, that's going to be fine. But I want you to have the experience of having to look at your original paper, determine what the effect size was or the correlation was, depending on what you... This is where I want you to reach out to me if you have some questions about this, want to work with you to help doing this, because it's not easy work. But you're looking and seeing what was the change, what was the percent change that people saw, or what was the correlation that people saw, and then enter that in there. Regardless of their sample size, what does your sample size need to be? So you'll use the G power to do sample size. It has the ability to switch out the variables, so I could actually put my sample size in there first and then see what my power is. That's scary for some, and that's another reason why people go after large sample sizes, because post-study, when you submit a study for publication, they're going to do it. They're going to take your sample size and they're going to run it through something like this and determine whether or not your statistical choices are powerful enough to say anything at all. And if they're not, it gets kicked back out to you. So so the discussion, the quiz, and then there's a special assignment due. Now, there's still some lag. We're still getting some lag in terms of people getting stuff in. I really want you to continue working on this. Before I left, I graded everything, and there was a lot of people that cleared. You know, they had items that went through. That's great. I also noticed that the assignment from Chapter 7, only one person did it. I think that's it. I just glanced at it a second ago. You got to get these assignments in. They're a part of the grade. So, and I know you're balancing a lot, but you know, you volunteered for this. So I'm expecting you to work hard on this. Get through those assignments so we have a study you have a study under development here. I know that I have a couple appointments with some of you coming up this week. Looking forward to that. But please take the time to go in and get those assignments done. They're all important in you leaving this class confused enough that, and I say confused enough, this will not all come together in this class. It will not. This is a first step. You will take more research methods type things, and as you immerse yourselves in them, but if you don't do that work, you're just going to be continually and perpetually behind in this. But you do the work, you make the best out of it, you kind of jumble through the whole thing and make your way. It took me several research methods class, and I still don't have it all. I mean, I've done research and I still don't, you know, I'm not like some of the people that I look up to. So get that work done. Reach out if you are behind on something. If you have not submitted some of the first 4 assignments, you are in deep trouble and you need to reach out to me. You can take that on as a responsibility. I've sent enough emails. You need to catch up and we need to work together, or you will not be able to finish this class. And and I'm not going to be doing any incompletes, not huge incompletes to help people get it done after. No, I'm not going to be doing that. So it's to get it done. I will help you, but I need you to reach out to me if you are behind. I have not looked, so I'm not pinpointing anybody. And I know some people are cruising right along I'm looking forward to their assignments here, and they're going to be pretty close to putting their study out there, like we saw the other student that I'm doing an independent study with. She put her study out. I believe we're going to be meeting this week, and we're going to be finishing this class in the next week or two with her, because she'll be analyzing her data, and she got hundreds of people. So that was pretty cool. She has a huge, not a huge sample size, but one that will probably give her good statistics. You don't need thousands, you need hundreds. If you have hundreds and you have a reasonable effect size, it's almost guaranteed to be significant. So I'm pretty sure she's going to see a relationship in her variables. And we will be publishing that for you to see. So you'll be seeing her final product, which is going to be similar to the final product that you're going to put out for this class. So get going. If you're behind, get in touch with me. If you're really behind, if you have any questions, I'm looking forward to the meetings I had this week. I can have more. I have all kinds of time. So please reach out if you have any questions. And good luck with all this. It's a little tough to get your head wrapped around, but want to reach out to me and talk about it some more, do some research, watch some videos that are out there about it, go back into your statistics stuff, see if you can find information there. It's all there. Okay, you have a great week, and I'll see you in the discussion boards.